Rather, the ratio itself of both was used because the problem or the question is asking for a percentage, and the percentage is what part of the whole. So that is simply the answer to example 1. We'll look at example 2 on the next page. So let me take example 2 in green. So example 2 says how many grams of sodium dihydrosulfate and how many grams of sodium hydrosulfate are needed to prepare 1.0 liter of a pH equals to 7.2 buffer, with the condition that the total phosphate concentration must be 0.15 molar. So, very interesting question right here. Let's take the question. How many grams of sodium dihydrophosphate and how many grams of sodium sodium hydrophosphate are needed to prepare 1.0 liter of a pH equals 7.2 buffer. pH equals 7.2 buffer, with the condition that the total phosphate concentration must be 0.15 molar. So problem, to solve this problem, you really need to understand what exactly is going on with the chemistry so as to understand exactly how to begin to solve it. So now let's look at some things. So here we are trying to prepare a buffer solution. That is clear from the question. And 1.0 liter of that buffer solution is what we intend to prepare. And we want that buffer to have a final pH. The buffer should have a final pH equal to 7.2. So we are going to be adding some NH sodium dihydrophosphate and sodium hydrophosphate. So I know that my buffer is going to be a phosphate and dihydrophosphate from the question. The buffer is going to be a dihydrophosphate buffer and hydrophosphate buffer. Okay? The buffer is going to be a dihydrophosphate buffer and hydrophosphate buffer. That is established. That means for this buffer solution, we have a little bit of, for this buffer solution, I'm going to add a little bit of both. So we'll add a little bit of the H2PO4 minus and a little bit of the HPO4 2 minus. That's how a buffer is going to go. So now I need to know how many grams. So you are going to add to 1 liter to get that pH of 7.2. But I have one condition, and that condition is that I need the total phosphate. Again, a condition was given here, and that condition is that the total phosphate should be the total phosphate concentration should be equal to what? 0.15 molar. That's basically all the clear parameters that are given in this question. So let's just go ahead and write down some equations and see how we can go from there. So from what is given, we have the following. From what is given, we have the following. We have H2PO4 minus undergoing dissociation reaction to form your H plus HPO4 2 minus. Here, this is the acid, and here, this is what? The conjugate base. Again, like we said, the acid is what is donating the proton. So right here is what? The proton donor. And of course, this the base is what is taking the proton or accepting the proton. As such, right here is what? The proton acceptor. Okay? So we have the proton donor and the proton acceptor. So I need the total concentration to be equal to what? 0.15 molar. Okay, so note that from the question, MB, the total phosphate concentration, total phosphate concentration should be equal to 0.15 molar. So that implies that the total phosphate concentration will be the concentration of the acid, which is H2O4 minus, plus the concentration of the conjugate base, which is HPO4 2 minus, and that should be equal to 0.15 molar according to the condition given. So this is what it means. This is exactly what the problem is associated with right here. The right interpretation of what is going on from the questions asked. Always note that questions can be asked in several different ways. One of the things you should see in biochemistry books, journals, etc., when they talk about the total phosphate concentration or the total carbonate concentration, they are actually talking about all of the different species. In this case, the phosphate that we are dealing with here is not the PO43 minus, rather the only phosphate species that we have in this question is the H2PO4 minus and the HPO4 minus, as we can see in the reaction equation. So the total phosphate therefore means the sum of both of those two species, which we add up together to give you the condition that is required, which is the total phosphate concentration of 0.15 molar. That is exactly that part of the question. That's what it meant. So if we are going to solve for each of these species. So if we are solving for the conjugate base, okay, solving for the conjugate base, solving for the conjugate base, which is your HPO4 2 minus, okay, what you have so solving for the conjugate base, you have the following. So if we bring out this conjugate base right here and make it the subject of the formula for what we are solving, so we have HPO4 2 minus will be equal to 0.15 molar minus concentration H2PO4 minus. All right. So next, we're going to go ahead and write down the Henderson-Hezebok equation for this reaction, and that will be able to help us solve the problem. So writing the Henderson-Hezebok equation. So right here, write recall the Henderson-Hezebok equation. You have, in this case, you have pKa, sorry, pH, not pKa. The Henderson-Hezebok equation is, sorry, all right. So we have pH, recalling the Anderson-Hezebok equation equals to pKa plus the conjugate base. In this case, now we have the conjugate base to be 0. Okay, let me just write that first. The conjugate base, which is HPO4 2 minus, okay, divided by the acid which is your H2PO4 minus. Great. So if we substitute this into what we already have as solution, what we have is the pKa. Note that the pKa for phosphate, okay, the pKa for phosphates here is 6.86. That's the pKa for phosphate buffer. So substituting that right here, you have 7.20 is equal to 6.86 plus the log of so in this case we already have this concentration equals this, so you just substitute that right there, 1.5 molar minus concentration H2PO4 minus over the concentration of the acid, which is your H2PO4 minus. Okay. Great. So we have a perfectly good equation here. This is my variables that I've carefully brought out. The concentration of H2PO4 minus. Let's go ahead and solve for that as follows. So if you move the numbers to one side of the equation and then take the antilog, what you have next is the following. So moving the numbers to one side of the equation, to one side of the equation, and taking the antilog, you have the following. Taking the antilog, you have the following. Okay, so you have the following, and um, what you have is your 7.20. Okay, I already said moving to one side, so that minus out. So when you move this to this side, it becomes subtraction. When you subtract that and take the antilog, what you have is 2.188 is equal to 0.15 minus the concentration of H2PO4 minus over concentration H2PO4 minus. So the next thing you do at this point is to take the algebra. You do algebra and you have, so next you do some algebra, then you do some algebra, then you have your H to PO4 minus equal to your 0.047 molar. So we've gotten the concentration of one of the species, and since you know, we'll take that in the next page. Since you know the concentration of H2PO4 minus, you can easily solve for HPO4 minus by substituting the value to your original equation. We'll take that in the next slide. Okay, so um, we recall here, let me just put it here again. Say we got from our simplification and algebra, we got this concentration equals to 0.047 molar. And we say, since we know for this species, we can easily solve for the HP HPO4 minus by substituting the values. So we'll just recall that equation. Recall that your concentration H2PO4 minus plus your concentration HPO4 2 minus is equal to 0.15 molar. Okay, so now we have value for concentration H2PO4 minus. So therefore, what you have to solve here for concentration HPO4 2 minus is equal to 0.15 molar minus this one here is 0.047 molar, and that gives you a value of 0.103 molar. Great. So we've known the two concentration of the individual species. So that the concentration that we need, so that is the concentrations that we need. However, what is needed is in grams. In the question, what is needed is in grams and not in moles per liters. So what you have next is to converting converting the moles to grams as needed. Converting the moles to grams as needed, you have the following. You have the following. So for n for n H2PO4, you have 0.047 molar, okay, moles. To convert to grams, you simply take the molar mass of this um, compound, sodium dihydrophosphate, and taking the molar mass, you have 120 gram over moles times 1 liter, 1.0 liter. So moles, we cancel moles right here, and liter, we cancel liter right here, because this is actually molar, and this actually here implies 0.047 moles per liter. Is the same thing, and that also is applicable here as 0.103 moles per liter. So when that cancels out, what you have is 5.6 5.64 grams of what? Sodium dihydrophosphate. Okay, so this is the answer that is required. 5.64 grams. All right, so I have 0.0747 moles per liter, and the molar mass of the sodium dihydrophosphate is 120 grams per mole, and is going to be in 1 liter of what? Solution. You easily cancel out and multiply, and what you've got is what? 5.64 grams of sodium dihydrophosphate solution. So this here gives us what? Our first answer. So to get for the second answer, which is next, you simply do the same procedure. So the next one will be sodium hydrophosphate, and what we have here is 0.103 moles per liter, which is the same thing as molar, like I said, and we times by the molar mass of this compound here, and what we have is 142 grams per moles times 1.0 liter. Now liter we cancel out liter, and moles we cancel out moles. So what you are left with is gram, and that gives you 14.63 grams, and that of course forms as second answer. Great. The second answer that is required. So in order for the total phosphate concentration to be 0.15 molar using the phosphate buffer system, you have sodium dihydrophosphate and sodium hydrophosphate at what? 7.2. I need to add 5 point, which is this first answer, 5.64 grams of sodium dihydrophosphate to 1 liter of solutions, and I also need to add 14.63 grams of sodium hydrophosphate so I could prepare the buffer of pH 7.2. So you are just using, so right here we have just used the Hesselberg equation to extract the necessary information, and playing around with it, we are and we playing around with it as well as doing